Hi, this is Algebra 1, Module 7, Lesson 10, the practice problems. Here we're going to just see what kind of the three forms makes the most sense as we're working here. So a golf pro practices his swing by driving golf balls off the edge of a cliff into a lake. The height of the ball above the lake, measured in meters, as a function of time, measured in seconds and represented by the variable t, from the instant of impact with the golf club is this. So here's our quadratic that is the height of the ball. So the expressions below are equivalent. Here's the standard form. They've already put it in factored form for you. And then here's the vertex form. So which expression is most useful in finding how many seconds it takes for the ball to hit the water? Well, and why? Well, that means the height would be 0. And so if we're looking for the height to equal 0, that would be the x-intercepts, right? Because that's the height is our y. So that means factored form would be best, right? Because the x-intercepts would be +6 and -2, which negative doesn't make sense. So it's 6 seconds. That's when it's going to hit the water. All right, which expression is the most useful for finding the maximum height of the ball? Well, if you're looking for a maximum or a minimum is the vertex. So vertex form would be best, because then the maximum height is going to be at 2 seconds with 7 and 78.4 meters. All right. If you want to know the height of the ball at exactly 3.5 seconds, which expression would help the most to find it? Well, you're just plugging 3.5 in for x. So really, I mean, you could, or for t, not for x, for t. So, I mean, you could plug it into standard form and solve. You could plug it into factored form and solve. You could plug it into vertex form and solve. So really, any would work the same. So that one doesn't really matter, just which one you feel like is going to be the easiest to do for you. Okay, if you wanted to know the height of the cliff above the lake, which expression would you use? Well, the height of the cliff would be when time equals 0, right? Your starting point. So that means the y-intercept and the standard form is that, right? Because if we plug in a 0 for our time, then 58.8 must be the height of the cliff. All right, so that's just help you out on that one. Okay, so now we're going to practice going between the different formats. So from here, they've given us the factored form. We need to find the standard and the vertex, make a table, and then graph it. So while we're doing this, if I'm going to factored to standard, I'm just going to multiply these out. So let's go ahead, and when I do my multiplication, I'm just going to go ahead and write it up here, x squared minus 3x plus 5x minus 15. So to simplify this, I'm just going to go ahead and write it over here. Standard form would be x squared negative 3 plus 5 is a plus 2x minus 15. Okay, so there's my standard form. So from here, I should be able to find my vertex. Let's scoot that over just a little here. Actually, I'm going to write it down below. Okay, so then I want to do x plus 2x plus, so here I'm going to try to find what my perfect square is. So I'm going to divide this by 2 to get a 1. 1 squared equals 1. So I really want my vertex form is x plus 1 squared, and that gets me a 1, but I have to get down to 15, so that's a minus 16, because 1 minus 16 equals negative 15. All right, so my table, if I'm going to start with my vertex, let's go ahead, I'm just going to use a text box for this. So here, let's see, my vertex is a negative 1. So I'm just going to go ahead and put a negative 1 in here, but then I'm going to, no, that's not going to take a lot of space. I'll just write them. Okay, so negative 1, so then I need negative 3, negative 2, negative 1, 0, and 1. So I'm sorry, these are not going to be very clear. 1, my thing doesn't draw very nicely, which is annoying, but it's a small space for this guy. So we know it's negative 1, negative 16. And then, so if I do 0 plus 1 is 1 squared. 1 minus 16 is negative 15. And if I do 1 plus 1, that's 2 squared, which is 4. 4 minus 16 is negative 12, which means I probably want to count by 2's on this guy because it looks like, at least on the y's. So if I go, let's say y's, count by 2. I don't really have a lot of space. I don't really have a lot of space to write all those with mine. So 0 is negative 15. So 2, 4, 6, 8, 2, 4, 2, 4, 6, 8, 10, 12, 14. So right down here is my 15. And then I need a negative 1, negative 16 right down here. And then 1, negative 12. So that's 15, 14, 12 is going to be about right here. So we're, oh, I forgot my negative 15 on the other side. There you go. That looked a little funny. Down here and then up here. All right, so it's going to be something like this. Going up. Not great. Not great because it's pretty small. Okay, next one. Here I'm given vertex form, and I want to go to factor and standard. Well, again, if I go to standard first, then that I could just solve this. So I know that, I'm going to give myself some space up here. I have negative 3 times, this is a squared, so it's going to be x squared minus 2x plus 1 plus 3. So then I'm going to multiply my negative 3 here. Negative 3x squared minus, plus 6x minus 3 plus 3. Well, minus 3 plus 3 cancel out. So my standard form is negative 3x squared plus 6x. And if I factor it, well, actually I can look at these. 3 goes into 6, so I could actually factor out a negative 3, and they both have an x. So if I divide both of those by a negative 3x, negative 3x squared divided by negative 3 is an x. 6 divided by negative 3 is a negative 2, and take out the x. So there's my factored form. That one works pretty well. Okay, and so let's see, my vertex is 1, 3. So 1, 2, 3, 2, 1, 0, negative 1. And so I need a 3 over here. So let's see here. if I do, oh, I didn't show the first difference and the second difference on the last one. I'll make sure and do it on here. All right, so let's do 2. 2 minus 1 is 1. 1 squared is 1. 1 times negative 3 is negative 3. Negative 3 plus 3 is 0. So 2 is 0. 0 is 0. All right. And then, oh, I kind of did those backwards, didn't I? Well, 3 minus 1 is 2. 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 plus 3 is negative 9. This one's going to be pretty steep because we have a dilation of negative 3 on here. So let's see. If I count by ones, can I get down to 9? I think I can. So let's see. 1, 3. 1, 2, 3. And then 2, 0. And then it's going to be 0, 0. And then 3, negative 9. So let's see where this one ends up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right at the bottom. That made it easy. And negative 9 on this guy. Here. Whoop. Okay, so we need to show those first and second differences. So here I have to do a plus 9. This one's a plus 3. This one is a minus 3. This one's a minus 9. And if I go to my second difference, so that was the first difference. My second difference, 9 to 3 is a minus 6. 3 minus a negative 3 is a minus 6. 9 minus 3 is 6. 3, this is 3. 3, here's, oh, going from 3 to negative 3 is minus 6. Here we go. There's my first and second differences. I'm going to go back and do it on this guy. So first difference. Here we have a minus 3, minus 1, plus 1, plus 3. So then my second difference is a plus 2, plus 2, plus 2. So we can kind of see how our first and second differences work on there. Okay, next one. Let's go to, from standard form, we're going to go to factored or vertex. So from here, let's go ahead and I'm going to go ahead and go to factored form first, just see what happens. So I'm going to factor out my negative. So I'm going to do, I don't really have much room for this. Let's do it over here. Negative x squared plus 10x, oh, minus 10x, because I divided out that negative, minus 10x plus what? Well, half of 10 is 5. 5 squared is 25. Well, when I multiply 25 by the negative, I get the negative 25. So that means my factored form is a negative x, and then it's minus 5 squared. And that would also be my vertex form because it's already in that perfect square format. So that was nice. Okay, so let's see. That means my vertex is at 5, 0. So 5, 0. So that's a 4 and a 3 and a 6 and a 7. So 6 minus 5 is 1. 1 squared is 1, negative 1. 7 minus 5 is 2. 2 squared is 4. That's a negative 4. Should be able to go by ones on this guy. So I'm going to go ahead and put my point at 5, 0. 1, 2, 3, 4, 5, 0. And 4, negative 1. I think this is my negative 1. You can't see the lines great on here. And then 7, negative 4. 1, 2, 3. I don't think there's an extra one in here. We'll put it right there since that's the fourth one I can tell. And boom. There's our graph. And let's double check our first differences. That's a plus 3, plus 1, minus 1, minus 3. And so then when we do this, there's a minus 2 to get to that one, minus 2, minus 2. All right. Next one. We don't have any of these forms. Oh, but we've got a graph. So what we do have on here are x-intercepts. So it looks like our x-intercepts are at -2 and -3. So that means my factored form, that gets me a 0, -2 plus 2, and -3 plus 3 get me zeros. So there's my factored form. So from here, I'm going to go to standard. And so I'm going to actually write that down here. So I've got my x squared. 2 times x is 2x. 3 times x is 3x. 2 times 3 is 6. So my standard form then is x squared 2 plus 3 is 5x plus 6. And so then from here, I can go to my vertex form. So x squared plus 5x plus, we don't know. But if I divide by 2, I get 2.5. And 2.5 squared is 6.25. So I have 6.25 and I want to go down to 6, which means I have to take away a 0.25. So my vertex form would be x plus 2.5 squared minus 0.25. Or I could put them all in the fractions. 2.5 squared minus 1/4. All right, so that means my vertex is at -2.5, comma, -0.25, which looks like that's about right on here, right? It's just barely there, but it's between the two. And lower would be a -3. Then I'm going to do -4, and bigger would be -2 and -1. So if I put a 3 in here, now let's do -2. -2 plus 2.5 is 0.5. 0.5 squared is 0.25. 0.25 minus 0.25 is 0. If I do a -1, that's a 1.5. And 1.5 squared is 2.25. 2.25 minus 0.25 is a 2, which looks like those are correct points. Now, when I'm doing my first and second difference, I'm only going to worry about these guys that have the whole numbers. I'm not even going to worry about my vertex. So I'm going from 2 to 0, which is -2. 0 to 0 is nothing. And 0 to 2 is +2. So from here, my second difference is -2 to 0 is a +2. 0 to 2 is a +2. So I still have my first and second difference. We just ignore this guy when it comes to this. All right. I think this is our last one for these guys. Okay, so here it says to skip the factored form. So what do I have going on here for my table? Well, it looks like my vertex is going to be 3, -6, which means my vertex form is going to be x. Oh, let's get our correct colors going on here. Is going to be an x minus 3 squared minus 6. If I go to graph this, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Oh my gosh, I can't see all these lines. So 1, 2, 3, 1, 2, 3, 4, 5, 6. That guy right there. Okay. All right. And then I'm going to go to 2, -4. 1, 2, 1, 2, 3, 4. Wait. 1, 2. I gotta go over to 3. I didn't go over far enough. So it's 2, -4. 1, 2, 3, 4. 3, -6. There we go. And then 1. Did I still not go over enough? 1, 2. This is Really hard to read for me. 1, 2, 3. Is 3 way over here? 1, 2, 3, 4, 5. This guy, I guess. And then 5, 4. There we go. Not being very accurate. My dots aren't working here. 1, comma 2. So 1, comma 2, which means this one's a 2 right here. And then you guys probably have this better on yours. 0, 12. I don't even know if we can go up to 12. So we're just going to do these guys. I don't know why my cursor's not clicking on here. Something's up. All right, there's the idea. All right, it says don't worry about the factored form. Let's go to standard. So x minus 3 squared is x squared minus 6x plus 9 minus 6. All right, which means my standard form minus 6x. I don't know why this isn't writing. There we go. 9 minus 6 is a plus 3. So my standard form would be plus 3. Right? Oh, wait a minute. I forgot to check for an a, didn't I? We better make sure we don't have an a before I do this. Okay, so if I plug this in to my numbers, I didn't even think about that. Let's see. Let's do 4. 4 minus 3 is 1. 1 squared is 1. 1 minus 6 is negative 5. Oh, it's a negative 4. Good thing I stopped. We'll go back on this. So we've got to do, there's some sort of dilation on here. All right. So if I add 6, I need to get a negative 4. So let's see. That means I have to be down to a negative 10, right? No. Let's see. If I subtract 6 to get 4, it needs to equal 2. So x plus 3 squared has to equal 2, right? Because 2 minus 6 is a negative 4. So if I put a 4 in here, 4 minus 3 is 1 squared. 1 squared, 1 times what equals 2? 2. So let's put a 2 in here. Let's try this. Let's try with 5. 5 minus 3 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 6, is that 2? Yep, there we go. So now we have what we did before, except there's a 2 in front. So x squared minus 6x plus 9 minus 6. So 2x squared minus 12x plus 18 minus 6. So 2x squared minus 12x. Why that's not writing? 18 minus 6, that's a 12 plus 12. There we go. Don't forget that a. All right. Verify each factorization by multiplying. So we're going to prove these work. So when I do these multiplying, that's an x squared, and then that's plus 16x. You know what? I'm going to do this with the text box. I don't know why my stylus is not connecting on here very well. We'll go ahead and type this. You can't even read what I'm doing otherwise. Okay, so we have x to the second plus 16x, and x times a negative 4 minus 4x, and then 16 times negative 4 is a negative 64. And so when we do that, we have the x squared, we have the 64, these guys combine to get the 12. All right, let's do it over here. So this I'm going to do to the side. So if we do x to the second with a distributive, and then we go minus 8x, then we're going to plus 8x, and then 8 times a negative 8 is a negative 64. So once we do that, maybe we'll use a different color. see if that makes a difference. 8 plus -8 plus 8 is a 0. They kind of cancel out, don't they? And that leaves us what's left. Okay, next one. We have x to the second power plus 16x plus, oh, we got 4x. And then we are adding 64 this time because it's 16 times 4 positives. And so again, these two, 16 plus 4, combine to make the 20. And last one. Here, we've got an x to the second power. We're subtracting 8x, and we're subtracting another 8x, and then we add the 64 because a negative times a negative is a positive. And so then we go -8 minus 8, we have a -16. So that's kind of our proof on those. Okay, factor the following expressions. All right. So 14, we have the two factors of 6 are 1, 6, 2, and 3. So it's a plus here and a minus here, so we're going to add. I'm just going to put add over here. Oh, I can't even read that. Let's do a plus. We'll just do a plus. We're going to add because it's got to be the same, got to be the same, got to be negative. So 2 plus 3 equals 5. So let's do x minus 2 and x minus, people have to be negative. 2 plus 3 is -5. -2 times -3 is a -6. Okay, over here. We have a positive here and a negative here, so we have to add, and they're both negative. So the factors of 6 that add to make 7, well, you know, it's an x minus, and factors of 6 are 1 and 6, minus 6. So they're both negative. Add them to get a -7, multiply to get a +6. All right, here we have 36. So we have quite a few on this one. So I'm actually going to write them off to the side here. So we've got 1 and 36, 2 and 18. Oh my goodness. 3 and 12, 4 and 9, 6 and 6. Okay. So because this is a subtraction, I know I'm going, or a negative, I need to subtract. But it's one of each. So between my ones here, I know it's going to be an x minus and an x plus. So now I need to subtract these to get 5. Well, 9 and 4 subtract to get 5, and I need a negative, so that means the -9 has to go here, and the +4 has to go here. So -9 plus 4, -5, 4 times -9 is -36. Okay, this one, 63. So they're both pluses. So I know it's going to be a plus. And so I'm going to use m this time. So both pluses, so m plus and m plus. 63, so two factors of 63 that add to get 16. Well, 63 I know is, there's no 2, it's 3, oh, 3 and 21, 7 and 9. 7 and 9 add to get 16. So back over here and do +7 and +9. All right, there. We have a -1, so we know we're going to subtract. And we know it's factors of 1. And so, well, the only factors of 1 are 1 and 1. And those add or subtract to get 0. We need a -3. So some will not factor. So this is A, does not factor. I didn't read that directions earlier, but there we go there. Okay, so here, it's a plus, so we know we're going to add. So factors of 2 are 1 and 2. Oh, they add to get 3, not 7. So this one does not either. Okay, how about 20? 49. What are the factors of 49? First we got to add. Okay, so both positives, so we're going to add. And so factors of 49, 1, 49, not 2, not 3, 4, 5, 6, 7. 7 times 7. Do 7 plus 7 equal 14? Sure does. So it's x plus 7, x plus 7. All right, this one. All right, we know we have to have two factors of 9 that cancel each other out. Because it's a minus, we know they're subtracting. So two factors of 9 that are the same would be 3 and 3. So we know it's an x minus 3 and an x plus 3. When we do negative 3 plus 3, we get 0. Negative 3 times 3 is 9. All right. And 3, both plus, so that means we're adding. Factors of 3 are 1 and 3. Those add to get 4, not 11. So this one does not factor. So at this point, if they don't come out as nice whole numbers, we're not factoring them. So which quadratic expressions above could represent the area of a square? Explain. I'm going to type that down here. So 23. Looks like the only ones that could be a perfect square would be the ones that are the same, and it looks like number 20. Number 20 is the only one that has two factors that are the same. So I think 20 is the only one, because all the rest, they're different, and squares have to have two factors that are the same. All right, 24. Would any of the factors, any of the expressions above not be side lengths for a rectangle? Explain. Really, I mean, all of these could be rectangles, right? Because you can either take or away or add, but probably not these guys, because if they don't factor, they're probably not going to be rectangles. So the ones that don't factor wouldn't create. All right, there we go. That should be it. Thanks for joining us. We'll see you next time.